Assalamualaikum and good afternoon, ladies and gentlemen. We are honored to welcome all the participants here today, to our moderator and our panelists, to the Road to Recovery Season 2, Episode 6. A great welcome and thank you to everyone for being here today. As one of the emerging technologies in the recent years, the smart grid has become a vital aspect in response to the energy industry challenges. Abundance of opportunities can be reaped from the smart grid technology to move the industry into a new era of reliability, availability, security, and efficiency that will contribute to our economic and environmental health. As such, MITE, together with our delivery partner Uniten, proudly presents today's webinar, Smart Grid and Drive Towards a High-Tech Nation. Ladies and gentlemen, the Smart Grid project is one of the components of the Sustainable Cities Development Project started in 2017 under the Global Environment Facility, participated by 28 countries and 28 cities in 11 countries all around the world. GEF has appointed UNIDO as the International Project Manager and MITE as its National Implementing Agency. The Ministry of Housing and Local Government, KPKD, spearheads the Sustainable Cities Development Project, while the Energy Commission chairs the National Smart Grid Technical Committee with Uniten and TNBR as project delivery partners. In realizing this project, MITE also collaborates with other strategic partners and stakeholders such as KETSA, PTHM, SEDA, SIRIM, MCMC, MGTC, Standards Malaysia, First Solar Malaysia Sendirian Berhad, and Systems Consultancy Services Sendirian Berhad. Among the targeted outcomes for the webinar is for a better understanding of smart grid implementation in delivering high-tech agenda, particularly to energy industry stakeholders, to provide audience with an opportunity to learn more about the smart grid and engage with experts on best practices within their social context, to disseminate information on the benefits of the smart grid to the audience, and also to allow the audience to share their experiences and insights, intended actions following the Smart Grid Awareness campaign, and commit to personal and community actions. We hope this Road to Recovery session will become a productive platform for us to share information and knowledge from panel of experts for the benefit of our society. With this in mind, we have invited our special moderator and guest panelists to be with us today. Our moderator today is none other than Yang Berbahagia Tan Sri Dr. Engineer Ahmad Tajuddin Ali. Tan Sri Tajuddin has been the chairman of SIRIM since May 2015. He also serves on the board of directors of Malaysian Industry Government Group for High Technology or MITE and holds other directorship positions in Linde Malaysia Holdings, Optimax Holdings, Aerospace Malaysia Innovation Centre, the Institute Integrity Malaysia, and is a member of the Northern Corridor Implementation Authority. He is also the Pro-Chancellor of Uniten, besides being the Chairman and the Board of Trustees of Yayasan Khazanah, in addition to the many other leadership roles that he holds. Without further ado, I'd like to invite Yang Berbahagia Tan Sri Dato' Dr. Engineer Ahmad Tajuddin Ali to start moderating our session today. Please welcome.
Thank you, Farah. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And very good afternoon to everyone, all the panelists, all the participants in this webinar. I know some even inform me that they are joining, so welcome. I hope this will be a useful interaction this afternoon with two people that I know very well, and we'll see how it goes. We have about 1.5 hours until about 4:30, yeah, Farah? And we will, manage this. We have a question and answer. Please submit your questions through the chat box or any other way that you can. We will try to address them. It is interesting for me to see so many participants who are joining, and you may not have noticed from the flyers that we have sent out, we have two key personnel involved in this project, as you were, on a higher level, as you were, not at the technical level as such, but they are the people who make things happen. So let me just start by saying something about MITE. Some of you may know us already. We are a government industry platform for discussion to basically address the area of high technology. We are about building national competitiveness and resilience in adopting new technologies and meeting the challenges ahead. So this is an ongoing thing. I've been with Mike since we started it way back in the mid 90s, some 25 plus years ago, and still very much involved today. So it is along that line that we have many projects, and one of it that is we're implementing, as Sarah mentioned earlier, is this program under the Global Environmental Facility, or GEF, which is under UN auspices, and we implementing one particular project which is to do with the smart city involving, as Farah mentioned, 28 cities in 11 countries, and in Malaysia, the project has singled out Melaka, Bandaraya Bersejarah, as a demonstration site, as it were. And the project involves two areas, which is on the sustainable city and on smart grid. The smart grid component is on awareness of the technology. And this, our Road to Recovery series of webinars that we are holding today focuses on, we have picked up this smart grid project, and the session is to provide awareness of the importance of smart grid in the context of national development and things that we are heading for to the public and to stakeholders. So in this Road to Recovery series, number 2 in our episode number 6, second in our series, second series, episode number 6, will allow these our panel experts to share their thoughts and insights on accelerating the smart grid project deployment in Malaysia, in especially in this pandemic and post-pandemic era. But before we start, allow me to provide a short introduction in relation to our session today. With the recent development of the smart grid project and the rapid challenges in developing a smart and sustainable city, it is crucial for us to consider this topic today, smart grid and the drive towards high-tech nation. Malaysia, as a nation, is striving towards becoming a high-tech nation. To achieve that by 2030, as stipulated in the National Policy on Science, Technology and Innovation 2021 to 2030, or NSNP STI 2021-2030. High-tech nation, in this case, is declared when a significant amount of cutting-edge technologies become a critical driver for productivity and competitiveness in the nation's economy. So in order for these cutting-edge technologies to be proliferated effectively in our industries, there is a need to have a versatile, sustainable, and adaptable energy delivery system and backbone. The solution to this would require our traditional energy grid to be transformed into a smart grid. Smart grid is a crucial enabler that allows the integration of multiple energy sources efficiently and at the same time promotes optimal management of energy consumption. Consequently, smart grid enhances the electricity grid to be sustainable and more efficient in the long run. Perhaps just to give a background, we will start, to give everybody just an overview. Let's start with a short video on the smart grid. Give it a video, please. Azam.
Our current electric grid was conceived more than 100 years ago when electricity needs were simple. Power generation was localized and built around communities. Most homes had only small demands, such as a few light bulbs and a radio. The grid was designed for utilities to deliver electricity to consumers' homes and then bill them once a month. This limited one-way interaction makes it difficult for the grid to respond to the ever-changing and rising energy demands of the 21st century. The smart grid introduces a two-way dialogue where electricity and information can be exchanged between the utility and its customers. It's a developing network of communications, controls, computers, automation, and new technologies and tools working together to make the grid more efficient, more reliable, more secure, and greener. This smart grid enables newer technologies to be integrated, such as wind and solar energy production and plug-in electric vehicle charging. With our participation as informed consumers, the smart grid will replace the aging infrastructure of today's grid, and utilities can better communicate with us to help manage our electricity needs.
Thank you. That is a broad overview of what this smart grid is about. Well, to elaborate further, perhaps, ladies and gentlemen, before we start with the panel presentation and discussion, we have asked somebody who is very much involved in this project. I would like to invite Professor Dr. Izham Zainal Abidin, Dean of the College of Engineering of University Tenaga Nasional, Unit 10, come the team leader from Unit 10 for the Smart Grid project. Prof. Izham will present a short introduction on Smart Grid and its relation to our session today. Prof.
Thank you, Tan Sri. Let me share my introductory slides here. Just a minute.
Okay.
Okay. Right. So, Tan Sri can see my slides, yeah?
Yeah, I assume this is your slide, number one. Which one?
The front page.
Road to Recovery Series 2.
Yes.
Yeah.
Okay. So basically, I will try to explain in simple terms about the project and what it is all about. So this particular project is called the GF6 Smart Grid project. So basically, this is actually part of a GEF global project on sustainable cities. It's an integrated approach pilot participated by 28 countries. 28 cities and 11 countries around the world. It covers a few of the SDG mentioned in the slides there, which is SDG 7, SDG 9, 11, 13, and 17. So Malaysia has been honored to be chosen as one of the pilot sites. In this particular case, it would be the state of Malacca. So the particular project in Malaysia consists of 4 main components, as you can see there. Component number 1 looks into the policy framework related to smart grid in Malaysia. Particularly, we look at some documents, policies, regulations, and orders and guidelines to see whether do we have sufficient of those for a sustainable smart grid implementation. The second component looks into capacity building, where we look at what would be the important courses that needs to be executed to ensure that our stakeholders and our users can actually understand what smart grid is all about and know how to use the technology related to smart grid to their advantage. The third component would relate to the awareness portion. In this case, we would like to tell the Malaysian stakeholders especially on smart grid and the benefits of smart grid. Based on our past experiences, awareness is key to this because we need to get the buy-in from the stakeholders on smart grid and its technology. That's why we have one of this forum today to actually introduce to people what smart grid is all about and how it relates to us as well. And the fourth part, which is also very important, which is the demonstration project. In this case, TNB Research are actually building a smart grid demonstration site whereby we will integrate smart grid technology elements, data from several sources, solar PV, EV charging and whatnot, to be included into a dashboard that we can use to actually monitor and understand the use of information in smart grid. So what I have here would be an example of the smart grid demonstration project currently being built by TNB Research. It consists of getting data from various sources, from smart meters, from solar PV, solar panels, rooftop solar panels, from battery energy storage, from solar thermal systems and solar farms. So this information are fed into the smart grid gateway, including the load that we shall use. In this case, we shall look at electric vehicles, EV charging stations, electric vehicle cars and scooters. And we combine all this data into a monitoring room or web portal in this case to monitor its impact of smart grid elements in the grid and see how we can actually utilize the information in relation to greenhouse gases as well. So the hope of this project is to actually demonstrate the importance and the advantages of using smart grid in Malaysia. So Tan Sri, that's basically it that I have here to generally explain and set the scene for you. Thank you, Tan Sri.
Thank you very much, Prof. Izam. It is, well, for me, brings back lots of memories because this is something that, although it's new, but it was on the mind for many years already. For me, well, it'll come out in the next few minutes, maybe. Thank you, because I'm still involved as a Pro-Chancellor of Unit 10, very much involved with activities at Unit 10. But before I start the session proper, I would like to take this opportunity maybe to introduce both our panelists for today. They come from organizations that are both dear to me also, because our first panelist is from TNB Research, have you heard, is the current Managing Director, Yang Usaha Dr. Muhammad Harifin Busroh. Dr. Harifin is Managing Director, as I said, of TNB Research, which, well, I think Dr. Harifin is aware, it was in, I think, 1997 when we started off TNB Research, when I became the first chairman of TNB Research, as it were. while I was executive chairman of TMB. And I'm happy to see that it is one of those organizations that has grown and is still very much in service and providing service back to TNB, as well as doing research on its own. So Dr. Harifin actually started his career in engineering as assistant chief charge engineer at our big power station, the coal plant in Kapar, the Sultan Salahuddin Abdul Aziz Power Station, as a coal plant operation and maintenance engineer. He was there from 1998 to 1988 to 1994. That was before I came back to TNB. Then he went on to do his master's and PhD studies in Leeds University in the UK in the area of fuel and energy. In 2000, he joined University Tenaga Nasional and assumed various academic positions from senior lecturer to the Dean of Graduate Studies. In 2010, he took the position as General Manager, Generation Environment Department of TMB Research, before taking his new role as Managing Director of TMB Research in March this year. His research interests are in clean coal technology, carbon capture, utilization of storage, and renewable energy. And the second panelist is also somebody very familiar to me because he is currently the CEO of the Energy Commission Asia, for which I was chairman, I think from 2011 to 2015, thereabout. And Razib bin Daud. Razib is CEO of Energy Commission now, has 20 plus years experience in electric supply industry, worked both in Malaysia and in Australia, and national power utility, IPPs and transmission network service provider, and renewable energy consultant. Razib was CEO of the electricity, head of electricity market operations of Energy Commission before, and he then moved to become the CEO of the Malaysia Nuclear Power Corporation. But he then returned back when he was selected to become the CEO of Energy Commission, administering the overall management and administration of the agency. So these are two very important people in relation to our topic or discussion today. Those who will facilitate, one on the development and technology, and the other one is perhaps more on the regulatory and development side. So for our panel this afternoon, the plan is that I will pose questions to them. They can choose to answer those questions or speak as they think fit on one after another, and then I will go. We have allocated 3 questions each, and they will address this question in relation to how they see their view on this subject of grid, smart grid in relation to those areas under their purview. So now first to Dr. Harifin. Perhaps I will start. As one of our project delivery partners for the smart grid project, what are the roles and commitment of TMB Research to drive and support the smart grid demonstration project in our Malacca initiatives? Perhaps I could share your thoughts on this, and then we take it from there. Dr. Arifin, please.
Okay, thank you, Tan Sri Moderator, and thank you for your kind introduction. Tan Sri, my fellow panelists, ladies and gentlemen, Assalamualaikum and very good afternoon. Thank you for having me in this forum. In response to your question, first, please allow me to briefly describe the key elements of smart grid. Even though we have seen the video, but I think let us deep dive a little bit so that later we can understand better and appreciate the role and commitment of TMB Research in supporting the smart grid demonstration project in Malacca. Smart grid can be briefly described as an electricity network that integrates electrical, information, and communication technologies through digital and other advanced technologies to improve the efficiency and effectiveness of the generation, transmission, and distribution of power. So as we can see there are three key technologies in a smart grid system. The first is the electricity generation itself, which include the energy sources, especially renewable such as solar, wind, and biogas, for example, as well as energy storage. The challenge of these energy sources would be its characteristics and behavior at which they function. And therefore, smart grid could efficiently integrate these unique energy sources to ensure the electricity grid is sustainable and as well as reliable. The second technology involved there is information, which is primarily in a digital form that come from various sources and provide information such as the equipment state and condition, consumption, efficiency, cost, and many others. In a smart grid system, a structured approach is provided to enable usable or meaningful information can be extracted from this data. This is where the art of data analytics comes in to assist the system operators and users in their decision making. And the third technology there is communication, which is needed to ensure each devices and measurement point communicate effectively so that the right control can be managed and at the same time will ensure sufficient security is in place to mitigate any risk of, for example, sabotage or illegal control of the network and the system. So with that, a very brief description of smart grid as a backdrop, TMB Research as a research organization that focus on providing technology solutions to the electricity supply industry, our role here in this project is to provide our experience in local smart grid development and leverage on our knowledge of TMB power grid ecosystem in crafting the latest engineering design and showcasing a new technology solutions for this Malacca smart grid project. More specifically, TMB Research will develop an open software platform that supports cloud-based virtual energy management application and Internet of Things, or people call it IoT now, where information integration, data analytics, and energy management will be implemented on a green energy and energy efficient infrastructures without neglecting the cybersecurity aspect, of course. This will provide the solution to effectively manage multiple data stream into the system and create a more usable or useful data for system operators and users. This will also ensure in getting the positive uptake of the advanced solution upon completion of the project, either by TMB or the local state partners through their upfront participation in the project. TMB Research also will propose and deliver the right solutions to technology contributors in Malacca that will allow their technologies to be integrated with the smart grid demonstration project, such as the large-scale solar farm, the EV charging system, the building energy management system, advanced metering infrastructure or smart meter, and the solar thermal system. The technology contributors that involved in this project include the 4 municipal council in Malacca, the state GLCs, local industries, and also universities. TMB Research also will develop and implement the integrated smart grid application to monitor, report and verify the energy consumption and energy savings based on renewable energy generation, as well as reduction of emission of greenhouse gas from the energy efficient program for commercial building and residence home, as well as from the low carbon transport such as electric vehicle. In this project, I was made to understand that up to 30,000 smart meter data will be collected and analyzed from residential homes and about 120 commercial or large buildings, and also about 30 megawatt of RE capacity from solar PV plants or solar rooftop, and at least 60 kilowatt of solar powered EV charging stations. And based on the design concept for this project, it is aimed to reduce greenhouse gas emission for Malacca at about at least 45,000 tons of CO2 equivalent per annum. So those are the role and commitment that TMB Research will be contributing for this project. That's it. Over to you.
Thank you, Dr. Arifin. That is a good, overall coverage of the role of TMB Research in this project. And if I may add, it is interesting that I think quite rightly that Malacca has been chosen for this demonstration site, because in a compact place, that city of Malacca, state of Malacca as it were, have all those ingredients that you mentioned, big solar farm, the smart metering project that TNB has been implementing for many years now. In fact, there is a project going on at the moment where they are getting the customer feedback. I think Razif will know about this, because I think it's commissioned by Suruhanjaya Tenaga to get how the people feel about this smart metering. The smart metering, smart meters that have been introduced for a long time in Malacca. And I know that because TNB approached me and to introduce to people in my university there, because I'm chairman of UTEM, University Technical Malaysia Malacca, and UTEM is taking on as a project to deliver, to test the customer acceptance of this new smart metering application in the state. So it's all within that total thing that you described, because I think Malacca has got all those ingredients: industry, the smart meter project, and of course it is within what we are driving also there, part of the total smart city project. Now let's move on to our next analyst to give you a refresh, so that before I come back to you on the second project. Next, I will move to Encik Razif to provide his view on the commitment of government in this very important area of moving from the traditional grid, as it were, that I was involved with when I was with TNB in the late 90s, to now moving more and more towards a smart grid with lots of technology being deployed, and so on. So as the body responsible for managing or looking after this electricity sector, perhaps Razif can comment on what are the roles and commitment of government and the commitment of the Energy Commission in driving and supporting these smart grid initiatives. Razif, please.
Thank you, Tan Sri, our former chairman of Suruhanjaya Tenaga Energy Commission, and also thank you, Tan Sri, for your kind words in the beginning. Assalamualaikum warahmatullahi wabarakatuh, dan salam sejahtera, and very good afternoon to all of you. Tan Sri, before I answer your question, I would like also to comment also Dr. Arifin, which just now gave us very good definition of a smart grid, because I remember when this terminology was introduced many years ago, many people are confused of the many definition of the smart grid. I think today, thank you, Doctor, you have clarified. If I may add, Tan Sri, this is very important combination of power system and information technology and communication. Very important combination that can unlock so many interesting benefit or products that we're going to discuss today. Tan Sri, Dr. Arifin, and ladies and gentlemen, in this particular project, we a role of Energy Commission or ST, actually they given a task for me to chair the National Smart Grid Technical Committee to supervise or to give some guidance on this in this project. So I think we are at the tail end of this project. I think we will wrap up soon this project under Global Environment Facilities number 6 under UNIDO UN auspices project. All right, ladies and gentlemen, as I think you always be reminded, we always from Sumberjaya Tenaga we always mention this energy trilemma, Tan Sri, balancing, doing the balancing act of this dilemma or trilemma of energy security, energy affordability, and as well as energy sustainability, environmental sustainability. This is what keeps us awake, if not every night, but most of the night. We have to strike, beautiful balance, or right balance between this. Sometimes can be a very competing objective. Somehow we have to trade off between those objectives. By the end of the day, we have to keep the lights on all the time because we realize there is a consumer expectations, especially nowadays. People can afford to lose even a single minute of power or electricity. We are too dependent on electricity. But anyway, at the back of the trilemma, we realize this rapid new technology advancement. I think we have to change. The word is we have to change. We have to modernize, as Tan Sri mentioned. We have to modernize the grid, optimize the grid. We have to get ready for future. I mean, Dr. Arifin mentioned on integrating renewable energy, on the character of specific character of intermittency or variability of renewable energy, and so on. So which is we're going to discuss after this. So I also would like to share. Now we realize the importance of this decentralization. When we conceived this power system in Malaysia more than half a century ago, the power coming from central toward one way toward a consumer end, but now the trend is moving toward decentralization or distributed energy resources, DER. That's the first D. The number 2D is digitalization, as Doctor mentioned just now. Important of embracing the IoT or information technology advancement in the power system. And of course, decarbonization, low carbon economy. We fully aware the aspirations of the society and the government. And the last is E, electrification. I mean, we're getting higher and higher demand. Not used to the demand growth or the peak demand. Not used to be double digit, but now a single digit, low single digit. But again, it's growing, especially in growing economy like us. You can see the transportation getting more electrified. Train, long distance train, metro train, underground train, LRT, MRT, car getting electrified, EV car, and because of low carbon objective. So all these D's and E, we have to respond. All these challenges that I mentioned, I'm yet to mention the solution. With all these challenges. So how we can still meet these challenges and also maintaining the reliability, the safety, and also the resilience of the grid with all these challenges, as I mentioned. I don't know, maybe I can say the new word here, we are future-proofing of the grid to make sure, with all this impact of innovation, technology we're going to embrace, and the grid is ready to accept all those changes. And again, we need another big picture here, Tan Sri, the enablers as well. As a role of regulator, we are not only regulating the safety of the industry, we're also regulating the economics of the industry, and as well as the quality service of the industry, our licensee. So we have to make sure there is a business case or business model for this venture, and as well as we understand I think the smart grids technologies are ready. Even I remember Tenaga have started way back when they modernized their national load dispatch center and their transmission grid way back many years ago. But now we are moving to a distribution network. We also to look at the policy, the regulatory, the law, the regulation, also need to modernize in tandem with all these technology changes, standard. The other thing that we also hopefully we can accept any international standard that we can adopt or adapt to Malaysian standard, and also architecture as well. So we need a seamless integration of this technology that we're going to deploy in our system. Okay, to answer directly, Tan Sri, your question on commitment of the government, I can maybe be specific on renewable energy. We are committed, government are committed to reach 31% of the capacity RE by 2025 for the whole country, and further about 40% by 2035 for the whole the country. Of course, in preparing for that level of renewable energy penetration, we need to strengthen the grid and so on. I think the other policy on National Energy Efficiency Action Plan on saving 8% by 2025, with saving of about 53,000 gigawatt hours of electricity. And of course, we one of the countries that pledged into COP21 Paris carbon emission intensity reduction. We pledged to reduce 40% by 2030 with base level of 2005. I think in power industry, we are planning to meet those targets by 2030. But I can also comment on another ministry, CASA. They also are responsible for the national policy on climate change, as well as Green Technology Master Plan. I mean that as additional policy by the government moving to a low carbon economy. Yeah. So I think I don't want to take so much of the time for the first question. But again, what is our expectation as regulator of government toward utility like Tenaga and also SSB and so on? We are hoping that with this technology, we can unlock the renewable energy deployment. Seamless, the first video shown on one directional of power, now we're getting two directional of power. We hope a seamless bi-directional of flow of electricity, and as well as all this communication. And also I mentioned standard, advanced automation, secured communication. This is our expectation. A system integration, protection, and integrated condition. The other angle of smart grid is the condition-based maintenance, monitoring of the equipment. These are our expectation for utility to be fully aware while we are a transition, or we are moving toward a smarter grid evolution toward smarter grid. Again, so in short, Tan Sri, government is very committed. Again, the trilema, we always want to meet all those objectives, but at the back of our mind, our head, we always aware of the new advancement in IT, communication, that will help us to grow, to smarten the grid, and to grow the renewable energy, and to make sure, what, in the end of the day, when we deliver the service, the power to the consumer, to the rakyat, is all reliable, secure, and affordable manner. Tan Sri, I think I've taken too much of your time.
Okay, no, very good coverage. You started off with a trilemma, but I think you end up with a multi-lemma. Because all those other things need also to be considered in the overall consideration for the adoption of this technology, especially those areas that you talk about, distributed generation and challenges of digitalization, decarbonization, and of course electrification and so on. Against that, we need to assure reliability and resilience of the grid. All this put together become those things that those people who are in charge have their sleepless nights in a way to make sure that all the demands of the various stakeholders are met. While generators and have got certain expectation in terms of returns, but as regulator and as the grid operator, you need to maintain balance and to ensure reliability and resilience and so on. All those have to be put together as living, issues that need to be addressed on a second by second basis, as it were. Yeah. Thank you, Chair Razif. And then we will go now to our second round, as it were. I'll go back to Dr. Arifin. The advancement of the grid technology, as you described earlier, require the roles of everyone for it to succeed in tandem with the global technological development. Things are happening around the world, and we are adopting some of it, we're developing some of it. So how do you see the smart grid as an important technology element of energy transition, as described by Razif just now, in terms of adoption of more distributed generation, solar, and other renewable resources, and so on? Your mute. Okay. All right.
Okay.
Okay.
I'm sorry. Okay. Thank you. Thank you, Tan Sri. Thank you for the question. It's a very important question, but a very tough one. As mentioned earlier by Encik Razif, smart grid is very important to unlock the RE. So it's a very important enabler. So it shows that the role of RE of smart grid is very important. And as explained earlier by Encik Razif, as our national energy transition aspiration, we are moving away from the traditional fossil fuel generation mix to more towards RE. Therefore, our electricity delivery network needs to be equipped with the capability to receive RE to support the dynamic two-way energy flow, and at the same time maintain system integrity and stability. As mentioned, I think also earlier, that at this moment, the electricity network can mostly support one way of energy flow, especially on the lower voltage side. In this regard, TNB has given the priority to invest in modernizing the electricity network to become the grid of the future, or as mentioned by Encik Razif, future-proofing the grid. And in other words, the smart grid that remains dependable resilient to disruption, smart with digital technology, and flexible in meeting the nation's energy transition needs. This is needed in view of the higher penetration of RE with its intermittency and variable characteristics that come with it. As I described earlier in the first round, that smart grid is an electricity network enabling two-way flow of electricity and data with digital communication technology, enabling to detect, react, and proact to change in the usage and multiple to changes in the usage and the multiple use issues. Smart grid also have the self-healing capabilities and enable electricity customers to become active participants. In this way, the big data analytics and IoT technologies are important drivers in smart grid. So in this context of energy transition, smart grid is then a key enabling technology to coordinate, to monitor, to manage and facilitate advanced applications such as virtual power plant or VPP, demand response, and transactive energy in the real-time manner. All of these are also underlined by the smart meter infrastructure that TNB has been installing from the middle of last decade. Virtual power plant is a cloud-based distributed power plant that aggregates the capacities of distributed energy resources for the purpose of enhancing the power generation as well as trading or selling power on the electricity market. Demand response is a change in the power consumption of an electric utility customer to better match the demand for power with the supply. Transactive energy refers to the economic and control techniques used to manage the flow of or exchange of energy within an existing electric power system with regard to economic and market-based standard values of energy. So in addition, smart grid also serves as the platform to enable seamless communication and information exchange among the domains to enable them to perform their intended function while maintaining the desired technical fidelity and acceptable economic parameters during their operation. So we can see here that the movement from traditional electricity grid to smart grid is also driven by other factors, including the deregulation of energy market, evolution in metering, changes in the level of electricity production, decentralization, as mentioned earlier, distributed energy resources, the advance of the involved prosumer, changing regulation, the rise of macro generation and microgrids, renewable energy mandate with more energy sources and new points and posts where for which electricity is required, for example, like the EV charging points. Recently, it's also interesting to note that recently in 2020, a study by Frost and Sullivan shows that smart grid is driving an increase in prosumerism, which is vital for energy transition. The report highlighted that the convergence of energy management system, energy storage, microgrid technologies, and intelligent communication and information platforms due to smart grid is creating a greener, locally managed, reliable energy supply mechanism while ensuring financial benefit for both utilities and the consumers. And as a result, consumers are being turned into prosumers and are able to participate or play a key role in the reliability of grid networks. This is something that we did not see, in many years ago. And it is interesting also to note that lately the concept of energy internet, this is something that I also become quite excited, has emerged from the limitless possibilities of energy sharing network formed by interconnection of electricity producers consumers, or now I just mentioned as prosumers, with renewable energy source, electric load, storage, and devices. Energy internet represents a radical transformation of traditional electricity system by orchestrating the real-time bidirectional power communication and money flow. So in other words, not just power, but also communication and the transaction, the money that comes with it. So the transformation is the result of ongoing renewable energy transition and evolution in the energy technologies, such as smart grid, as mentioned just now, storage device, and also vehicle to grid. Energy internet rely on the wide spectrum of information and communication technology, such as IoT, artificial intelligence, now blockchain, and also the various payment interfaces. So these technologies have achieved a state of evolution to facilitate seamless bi-directional flows in the energy internet. Of course, obviously, all these good things about smart grid or even energy internet come with some challenges. For example, there is a consumer concern with regard to privacy and personal data protection, because now we are kind of sharing information and customer information. Another challenge is the overall cybersecurity aspect, which is of course typical in all industrial environment where the digitization and digital transformations are ongoing, and where data become a key economic asset. The other challenge is in the aspect of regulatory changes, the complexity in integrating sources, systems, and partnership between the various players in a deregulated market. So this is where perhaps the role of Suruhanjaya Tenaga is important to have to coordinate all these issues. So in summary, we believe that smart grid is very imperative in our journey towards energy transition. In fact, the smart grid technology came to TNB way before energy transition was even introduced. We think that it is only natural that smart grid, and perhaps in the future as well, energy internet, will contribute towards the energy transition journey with all the reasons that I mentioned earlier. So with that, I pass back to Tan Sri.
Thank you, Dr. Arifin. Well, I'm a prosumer myself because I do have NEM2 on my roof, and so I'm selling back to TNB. But those things that you mentioned are real today. I mean, when I was with TNB, it was at that point that we are starting off, looking ahead, but now it become a reality. So a lot of challenges on the technology side and on as well as on the regulatory side. So with that, perhaps go back to Razif. I have to comment beyond what you have said earlier on the regulatory aspects of the smart grid, the importance of the grid, and to enable energy sustainability in the context of the energy trilemma that you talked about earlier. So maybe another view of what you have said earlier.
Okay, thank you, Tan Sri. Yes, to move in tandem with this technology, we also have to also modernize our regulatory framework. In fact, we have to be well ahead of time before this technology comes on our shore. But anyway, I may recall when we started the large-scale solar right after feed-in tariff. We started the solar and then net energy metering that we introduced. We established those guidelines, framework, how we regulate in terms of technical and also economics as well. But this time around, we want to look at it holistically. That's why in this project, part of the project, actually one of the deliverable, actually Tan Sri, what we call this framework, regulatory, a single smart grid regulatory framework. I think Prof. Izham mentioned in the beginning. This is one of the deliverable in this project. We really look forward for this conclusion of this framework. And as we speak, we are reviewing the Malaysian Grid Code. We will revamp the Malaysian Grid Code and we will look at all those aspects on the current grid code to address all those technology and parameters that we need to introduce to give the right signal and to give the right regulations or rules to govern the intricacy of those participants in the grid, as well as all those devices connected to the grid. I think this may also apply to the other code. We have a distribution code. They may apply to that code as well as other guidelines issued by Suruhanjaya Tenaga, ST. Yeah, that on our current project on regulatory framework. But of course, let me relate to your question, Tan Sri, relate back to the trilemma, how we actually benefit from this smarter grid. On energy security, of course, the word is resilient. We are hoping that, with higher level of renewable energy penetration, our grid is ready to respond, to react accordingly, to make sure the security of the network is still intact. And then the improvement of the SIDE index for the consumers, and system minutes on the transmission level, and the other important criteria in our security is LOLE, loss of load expectation, one day per year. All these criteria in security, we hope will benefit from this investment that we make in modernizing the grid. And in terms of affordability, Tan Sri and other gentlemen, Doctor as well, we are hoping that, when the word that I mentioned, optimize, with optimum level of operation, we are hoping that we reduce or we give some saving to the overall generation cost when energy being generated, produced, and been transmitted or delivered to the consumers. With smarter grid, with more control, maybe we are hoping that giving all the efficiency to this delivery system of the electricity to the consumers will result to the saving, overall saving or net benefit to the consumers. Of course, this is obvious on sustainability. As we go higher penetration of renewable energy, we are readying up, or we preparing for the grid to embrace more higher RE penetration. So that contribute to the lower carbon emission from fossil fuel toward renewable energy resources. Yeah. So those are the objectives that we think that by modernizing the grid, embracing the technology, putting the right investment, capex, we get the return, the investment that we can pass back to the consumers in terms of saving and affordability and so on. But again, we have to be mindful that security is very important. Keep lights on is very important while we are moving toward the other initiative. I think I forgot to mention also cybersecurity, also a part of the element that we also concern, or we also realize that very important to address. I think we have many meetings with utility and also with Majlis Kemasan Negara and cybersecurity that this is we don't want to be exposed our network, our power system network toward the imminent threat on cybersecurity. That's always important that we safeguard the infrastructure, from the cyber attack. All right, I think that's all on my note here, Tan Sri. I have some more note if you want. Okay, let me try to add a few things before the last round. The word self-healing, I think Doctor mentioned about the self-healing function of a smart grid. I think we welcome the self-healing features of the smart grid. So that is save the restoration time. When we have the tripping of the plant, or we have some incident on the network. So the self-healing will respond to that dynamic event on the network. I think will not be result to this outage, system outage. These are features that we welcome on the smart grid. And empowering, Doctor mentioned empowering the consumers. Yes, we realize the trend of the prosumers, the consumers that not only consume as well as produce electricity on their own. So this is empowerment that we also are hoping that as I mentioned, energy efficiency initiative that government introduced way back then. We are seeing the consumers' behavior have changed toward more savvy on consuming electricity by buying, energy efficient products. ST we also issue the maps, the star rating of the equipment, as well as under our regulations, we regulate the building at certain energy that they consume with energy manager and so on. So these are the low-hanging fruit as well. We see the benefits of having saved the electricity in the first place. Yeah. So if you couple that saving electricity, you couple with a prosumer's initiative, that will be a potent, again, the word I use, the potent combination. If you combine energy efficiency with renewable energy, that will be a perfect recipe moving forward. But if you waste energy, you have less benefit on producing your own renewable energy on your roof. So that we always encourage consumers to adopt energy efficiency practices and behaviors respond toward energy saving. Yeah. And I think I mentioned the cyber attack. The demand response. Doctor mentioned about demand response. So we welcome. We have done a few studies on demand response. So how to incentivize people to actually let go their demand in certain scenario that we don't have to result into dispatching very expensive power plant, that we can actually incentivize people to take up their load voluntary, but of course with some incentive. That there's also some saving by avoiding putting up expensive generation when there's some events of shortage of generation. Hopefully we come to that event. But anyway, there's the insurance that we put in place in the system here. But again, the doing all that, in the end, we have to meet the capacity, satisfying increasing demand of electrical energy, reliability, satisfying quality, reliability of electricity, efficiency from the whole value chain from generation all the way to the consumers end, and also sustainability, integrating all those renewable energy, low carbon resources into the system.
Okay.
Thank you.
Thank you, Zeb. We are running short on time now. Very interesting, but we still have this third round to go. And before, I will not let Prof. Isham go with just his short presentation. I think there's an opportunity here. I would like to warn him. Perhaps he can, in his day job as Dean of College of Engineering, Unit 10. Yeah. You heard what the challenges are that both panelists have been addressing and talking. And to me, one of the ways that we must ensure the future is that we have the people who will be the people who look after this smart grid and so on. How is Unit 10, or university for that matter, responding to that. I don't want you to answer now. You prepare your mind. We'll come back after this third round. How do we prepare our future engineers with all these ingredients is required here? That they have to have this digital technology, even if they're doing electrical engineering or mechanical engineering or whatever, that they are fully equipped to handle the demand of the profession, engineering profession in the future. Think about it and maybe give you 5 minutes to answer when we finish the third round. So for the third round, Dr. Arifin, as a leading research and solution provider in the energy industry, especially locally and also in the region and the world maybe, how do you foresee the role of TNBR as a research entity in TNB will be able to help to strengthen the development of smart grid implementation in Malaysia?
Okay. Thank you, Tan Sri. This is something that is we are very much looking forward and excited to be able to participate and contribute towards the development of smart grid in Malaysia. For your info, Tan Sri, at present, TNB Research has a dedicated research unit on smart grid, as well as other research units such as on power system, utility automation, substation, ICT, RE, and many others. Just to highlight a few of our research capabilities, number one is on secure and intelligent substation automation system, which covers the advanced distribution automation scheme to enable controller-free operation and fast restoration switching in selected TNB distribution network. And number two, on smart energy management application. Number three, on the communication network. Number four, on transformer health monitoring, which had the ability to perform transformer failure prognosis using analysis of various transformer oil data. Fifth, IoT, sensor management, analytics, and database tools. Number six, deep freeze system, voltage sec. Number seven, community scale energy storage system that provide utilities and customers with the technology to implement an effective energy management program and the capability to store electrical energy generated from both utility and renewable energy sources. So those are a few of our example of our research capabilities. So with that, one gap that we feel that TNB Research could address in driving the smart grid implementation is the applicability of the solution in the Malaysian environment. This is where TNB Research, we feel that we can fill the gap by establishing ourselves as the referral for the international standard of smart grid implementation in Malaysia. TNBR can do its part by advancing the technologies that were mentioned before, such as the virtual power plant and demand response. For info, Tan Sri, we are currently installing virtual power plant at 4 sites, one in TNBR, the second in Unit 10, third in Genting, and the fourth in KLIA, that will demonstrate the technical feasibility and its business viability. There was also a feasibility demand response project completed in 2020 that shows that there is a flexible customer that could provide capacity and spinning reserve service to a TNB system operation. So with that, TNB Research would like to serve as the competent entity in evaluating, testing, and proposing the relevant solution available globally for our Malaysian market, guided by international standard. For example, IEC FIN 1850, the digital substation. This IEC 1850 is also applicable to other smart grid domains, such as distributed generation, electric vehicle, and energy storage. The standard provides standardized data model and communication services that enable interoperability. As mentioned earlier, one feature of smart grid is it receives a lot of data and communication, and they're coming from various vendors, and they can come with various languages. So we need to have a kind of standard that can integrate and make all the components can communicate. And also TMB Research as the entity in TMB, we would like to further strengthen the development of smart grid implementation by focusing on technology customization based on established international standard again and guidelines, such as the publish of IEC, CGRID and IEEE. Because most of these smart grid technologies are being driven by big technology players, and most known solutions are already available in the market. So in short, finally, we at MBR is ever ready to demonstrate smart grid technologies for any party that wish to pilot related project to fulfill their sustainability agenda. And in fact, we have been approached by many city council and local authorities to see our opinion and views on how smart grid technologies can be part of their smart city and township journey. Inshallah, we are happy to participate and contribute in whichever way that we could for the national energy transition agenda. Thank you, Tan Sri.
Thank you, Dr. Arifin. I think your customer is ready-made. As far as I see, you have the regulator that's wanting so many things to be done, to be looked into. You have, well, your own mother company, TNB, which has to manage the grid and to do it in a way that is most efficient, that is most, well, from a business standpoint, gives the highest returns, as it were. So I think the challenge is there to just to be delivered. Now, if I can go to wrap up the third question to Che Razif, perhaps in looking forward into the future, especially in the context of what has been around for quite some time, the future and the ASEAN power grid initiatives and so on. How will these smart grid initiatives and will sort of move towards in the future?
Okay, thank you, Tan Sri. I think you are fully aware that there's always been a dream of ASEAN to have this ASEAN power grid being built one day. But of course, it's not been at the speed that we wanted. But again, connectivity is very important between ASEAN countries, grid connectivity. That will spur a lot of other benefits. I think many audience here aware that I think five years ago, if I'm not mistaken, we started this power integration project that we signed between Laos, Thailand, and Malaysia, that we able to purchase energy all the way from Laos via IGAT or Thai network grid. So that's a clear path for multilateral power trading or power transfer within the ASEAN countries. I think we look at a Europeans model, at least on, if not the market, at least on the technical function. We realize that European managed to enhance or grow their renewable energy despite all the challenges very fast, because they are fully interconnected. They can buy or sell power or import power from any other countries in European when they have a shortage or they have issues of backup or standby power. That will help. Living in Ireland itself will not have the grid to be very resilient, but having heavily interconnected system, when you're talking about a microsecond or second, that will help, that will benefit increasing penetration of renewable energy with variability characteristic that we mentioned in the beginnings. That we see that benefit. That's why we encourage future ASEAN realizing ASEAN power grid, that we may one day be connected to Sumatra, and who knows, to Philippines and Borneo, to Peninsula, and so on and so forth. There's a long list of ASEAN power grid project. But again, there are challenges when we start talking with ASEAN counterpart. We have to harmonize the technical standard. We have different standard. Unlike Europeans, they are unions of political, but we just a club of ASEAN. We cannot impose beyond our border jurisdiction. So we have to sit down to harmonize the grid code, all the code, the technical code, to make sure that when we start a flow of power between inter-country, we comply to a certain minimum standard that will not jeopardize or interrupt the other grid. Yeah. So those are the challenges that we are overcoming. Actually, we have many committees in ASEAN to look into this harmonizing the grid. And that again, when you integrate, of course, you will gain benefit from a certain country that rich in resources. The certain country we high demands of energy, that we can will power from that resources into the load center of that country. That will optimize the demand and supply between ASEAN countries. At ST level, I think these are the project, Malacca project, this particular project that we're talking today, we are really supporting this project as a showcase to create awareness and also to demonstrate this the technology for the future. And we learn a few or many things along the way before we develop a strong framework or guidelines or regulatory changes. That we hope that with all these collaborations between the government agency and utilities, as well as the state, Malacca, and mine as well, and the other agency, we hope we can realize the benefits of this project, or the objective of this project. I think that's all I can say for the last one. Thank you.
Thank you, Razib. Well, we have come to the end, but as I said, the challenge of the future is also to produce the people that will be necessary to power the power system. I mean, the engineers and people who will be operating the grid system and so on. So we have here Prof. Izam, who is in his day job, as I say, beyond the smart grid project, is a dean of School of Engineering of Uni 10. How is the university, meeting this challenge? I went to school to university 50 years ago, more than 50 years ago, when we have only one computer, one big ICL 900 something, to be used by everybody. Now everybody has got a computer in their own pocket and so on, iPad and other things and so on. So what more into the future, the engineers that we produce must be able to handle all these new technologies and be useful in terms of using this technology to operate the grid and so on and so forth. So no more the men who go and operate the coal-fired power plant, very mechanical in those days, but it's now a lot more IT is into the system. What's your response?
Okay, Tan Sri, very interesting question. Of course, that's the main challenge for the universities nowadays, because we have now go beyond the normal traditional engineering that we have learned those days. Nowadays, the engineering program is very integrated with each other. In fact, in University Tenaga Nasional, we actually incorporate each element that we teach in the engineering to cover several aspects. For example, for mechanical engineers, they will learn a bit on electrical and also control. For electrical engineers, they will also learn about power generation and renewable energy sources. For civil engineering, they will also learn about transportation and also energy transportation, like transmission lines and so forth. So nowadays, the universities are looking into a very integrated program. Of course, we don't have a bachelor in engineering per se, but we still have our usual engineering program based on the domains. But then we incorporate certain elements in there to ensure that our graduates have the basic knowledge to learn further. In addition to this, in relation to smart grid and sustainable energy, we also incorporate a few programs related to renewable energy. How do we actually incorporate that using smart grid technologies? And of course, those basic knowledge, for example, data analytics, machine learning, and also artificial intelligence. So nowadays, we can't teach everything, but we teach them enough for them to learn further when they go out into the job market. Asri.
Well, I think that sums everything. As I said, I went to school when computer was in its infancy. When I started work, actually when I came back to Tenaga, if you remember, I was more or less brought in because of the power blackout in 1996 and so on. It's still very much a conventional grid at that time. But the first IT challenge was when Y2K. You may not remember. Y2K. We had to really look at our computer systems and so on to see whether it can handle the Y2K issue. And then, of course, we move on and on. Now everything is computerized. This morning, I attended the CIRAT TNB session on smart switch gears, which now is moving away from the air insulated more towards gas insulated, so that it is safer and so on and so forth. And a lot of more of integration of smart technologies into that. You can do remote control, and all this now it become normal, natural in the system. So go back to what Prof. Isam said. The challenge is to produce the engineers of the future that is able to cope with this from the start. Because technology developed during our time, my time especially, I have to move on. You may be wondering, why do I choose to chair this? As chairman of MIND, I can just say, get somebody who will do all that. But deep in me, I want to learn. I want to know a little bit. It forces me to learn. And of course, to sit and listen to this is rewarding in itself. So that's among the motivation why I'm sharing this session, apart from the fact that the two people are known to me. So we have a lot of questions, actually. Let me try just, we have not so much time. I'll be guided by the Secretariat. But for example, I mean, they have posted the question I have in front of me at the moment, which is true, it's very true, that to the layman, to the people out there, to the customers, TMB consumers out there, smart grid, all they see, maybe, yes, the smart meter, yeah. But beyond that, there's a lot more that, as you have described. The question is, what about the role of the smart grid in handling intermittency of renewable and stabilizing the grid? Mungkin Razif, you are nearest to this.
Maybe appropriate, Doctor, but I make an attempt because I also passionate. I'm a trained power system engineer, Tan Sri. I'm also know a little bit on power system. But yes, correct. We're looking at future battery energy storage to manage the variability or intermittency of renewable energy. You're right, stabilizing the grid. So, a lot of what you call inverter power electronic been introduced. Maybe soon, I don't know when, we have a lot of spinning turbine. Maybe one day we are now actually less and less spinning turbine, providing inertia into the system. A lot of inverter. I think I Googled somehow inverter also try to emulate some kind of inertia. As turning turbine being replaced by inverter, power electronic base. In solar inverter, in wind inverter, and so on, they try to emulate some kind of inertia, I can't remember the terminology, but again, also there is a role of a smart grid with battery energy storage system and intelligent data that can predict event risk of something happen. They can predict, and not to forget also what you call a special protection scheme, smart protection scheme that the operator or the grid owner can configure in such a way that in the event of something happen, they will try to respond in a manner that can prevent the grid become unstable. There are many systems that I am personally aware in Tenaga scheme. They are integrating the protection, the control, the monitoring, their energy management system to make sure the grid remain resilient. As I mentioned, there are many levels of smartness. You can go to the grid level, transmission level, the distribution level, all down to the consumer's level. There are, if you integrate, information technology, communication, the smartness of the device, intelligence of the device, you can manage, you can prevent, touch wood, will not happen, you can prevent instability to the grid. Right, we are actually, as I mentioned, as we increasing the level of penetration of renewable energy, being specific, the variable renewable energy like solar, we need to make sure the grid is ready for these resources, this type of resources, and to prevent instability and so on. Something not to our wish to happen here. Did I answer that question? But again,
yes. In fact, you have answered a few questions ahead. There are a few questions relating to how do we handle this intermittency of the RE, and how about, in a way, about costs also. How much can the grid tolerate in terms of RE penetration to maintain, grid reliability and so on?
Yeah.
It's along that same line. Any comment, Dr. Arifin?
Yeah, I think as mentioned by Tan Sri, they already, deliberated quite well. Perhaps, in my opinion, that is the very essence of smart grid. In the design of the smart grid to that particular locality or city or state, that is exactly the thing that need to be considered in terms of the energy sources available, in terms of the pattern or the trend of the consumers, the type of industries and so on. So in other words, those things need to be considered in the design of the system, so that all these issues of intermittency, the variability and so on will be taken care. And since smart grid, one of the elements is communication and information. This is the very essence, so that all this information will be fed to the to the brain, to the software that will integrate and coordinate the matching between the demand and supply. So I think, so that's why we need to have the smart grid in order to accommodate that kind of issues.
One question has been posed, with the current technology state of the grid, a smart grid, what's the maximum share of intermittent RE in the total system capacity that the grid can tolerate?
I was made to understand from one report by single buyer that, or the GSO, the system operator, at present the 20% is the comfort level, 20%. But the system can be designed or can be tuned up to 30. So that's basically the kind of level of comfort that the system can tolerate. That's what I was meant to understand. But for detail,
if I may add, Tan Sri, thank you, Doc. Who come first? Actually, the grid came first, Tan Sri. We have developed, we have invested the grid. So when the RE came later, but the grid at this time is ready to receive 20 or 20% of variable RE, the VRE, especially solar. We don't have wind here in the country. But to move beyond that, that's why there is ongoing studies by GSO to look into higher level of penetration. What is the impact technically? How to secure the system to make sure we meet the objective of system security. There is ongoing studies. They are hoping to complete, I think, before end of the year. So we look forward for the final recommendations by the grid system operator, as well as, I think it's not complete if I not mention about economic. That's our role as a regulator. On the economics, there is also ongoing studies by single buyer. They are looking at the RE integration costs, because I seen the question on economic as well. So we just want to make sure all those costs of renewable energy integration will be factored in when we determine the tariff, the generation costs, and we have to make sure these costs are fairly distributed among the participants or the consumers. We don't want to overburden certain sector or under recovery on a certain sector. That's why important that we determine the cost of RE integration into the system. Then we can fairly distribute the cost. Again, technicals, economics, that will make a great policy moving forward. Yeah.
Yeah, I would like to assure the listeners out there, the audience, that this question is visible to all the two panelists. So although I may not put the question to them, they can answer it knowing what the questions are. I mean, what Cik Razif has mentioned is this question relating to how can this smart grid implementation can guarantee us as a consumer that the cost of smart grid will never be borne by the consumer in terms of increasing tariff. Yeah, so that is the answer to that question that has been put. Having been where I have been, I can also feel the dilemma. But today I'm not responsible for it, so I can say it's not my problem. But honestly, with the introduction of distributed generation, RE, through feed-in tariff, through NEM 2, NEM 3, and so on, so there are a lot of generation. But when the sun is not up, somebody has got to come up with the power. So PNB has got to bear the cost of that standby power, as it were, to be available. They have to make that investment. So here is where ST will make sure, I'm sure PNB will come with their reason why they should be compensated. But ST will have to be fair. Both the consumers as well as the main generator in this case, that their investment into those spinning reserve that it was mentioned just now, to those standby capacity that is needed when others are not generating, especially during the night when there's no solar. So that cost is borne by TNB. So as I said, I know it. I was responsible. I had to deal with that, but now it is somebody else's problem. So as a regulator, you have to be fair both sides. Any comment?
Yeah, you're right, Tan Sri. That another sleepless night for us. But again, we take up the challenge. That's why together with the GSO looking on the technicality, security, and single buyer looking at the economics. So we combine those findings, then we come out with the policy that's fair to all. We will embrace the new technology, but of course there is associated costs that we really have to determine. And then we have to fairly distribute the costs accordingly. Of course, we will optimize the cost benefit analysis and so on and so forth. The end of the day, as you mentioned, you rightly mentioned that there are traditional way of generating and there are new way of generating. this can be complement each other. Again, I believe that they can live in harmony, and but the word fairness is important as regulator. We make sure that we appropriate how you apportion that cost by not shifting the cost to the other party that not responsible for that reason.
Okay, I think this is a question that is of this sector is a affected party, not a responsible party. Yeah, is there any guarantee from cellular network providers about the service in abnormal situations such as when wind, stormy, heavy rain, lightning conditions, and so on, for downtime during that time, on the availability of cellular network? Because the current technology requires that system to be also available. Power has got to be behind there, but to power the cellular network. But then the cellular network itself must be also available to power back to the power system. Any comment?
I'm not sure whether TMB too dependent on cellular. I think cellular is their backup. I'm not sure, but I can be maybe Dr. Dr. Arifin will confirm, but TMB have their own extensive fiber network.
Yeah, fiber.
Depend
Yeah.
on the cellular, maybe it's as a backup. But again, the smart meter TMB infrastructure, they don't depend on the cellular. They opted to I can't remember the technology, but something that they hop from one meter to the other meter until they reach a system before they pass to their own fiber. Yeah, I tried to recall the terminology, but I cannot recall the terminology. But I don't think they're too dependent on cell network. Dr. Arifin, you have any info? Cell network?
I'm not sure about that. I think as you mentioned, there are various options for communication apart from the cellular network, because we also have our own fiber optic. So
maybe this question for the future, maybe during IoT, I don't know, maybe I don't know, Tansri, maybe in future, maybe we are too dependent on cell for IoT technology, is it?
Yes. This is a very interesting question from Datuk Khalilur Rahman, my fellow board member of MIT, and of course SES system technology and so on. Is there R&D done to study this possibility? Is it possible to design the charging infrastructure to be charging and discharging back into the grid when the need arises? I think he's referring to if there is any grid failure, when all the individual power producers also loses the ability to produce power because our grid system is interconnected. And I know as what happened in 1996 because of the control system, our control system worked, and that's why each power plant shuts itself down when the frequency drops below a certain level at which the trigger is set or the setting is set. So the protection system worked and power plant shut down one after another because it is designed to shut down if the frequency drops below a certain, I think a few percent below 50 hertz. And that's what actually happened. So in this case, also the same, I think the question is along that line. But I can't locate, it's too small on my screen. That's Well, we have passed the time. Farah, is there? I know you have indicated that we can extend a little. But can I have any go backwards now? Cik Razif dulu, your last words. Any last comments you'd like to make with respect to this project on smart grid?
Okay, thank you, Tan Sri. Thank you for having me today on behalf of Suruhanjaya Tenaga or Energy Commission or ST. We thank for Mike for inviting us to participate in this webinar. I think we are fully supportive of this project. I think we look forward for the conclusion of this project that we actually heavily or actively involved in this project under UN, UNIDO.
Yeah.
Number one. Number two, we must get ready in all aspects to modernize the grid and to embrace new innovation technology while meeting those Trilima objectives, security and affordability and environmental sustainability. And I agree with Tan Sri, not only Trilima, it's Mati Lima. I don't know whether this word Mati Lima, but it's come from all angles. But again, that's what makes this engineering or this particular sector interesting, dynamic. Is highly relevant and highly related to how the country economy is growing. We see the importance of our sector, electricity industry, to support the demands of electricity for the economy to grow, as well as all these low carbon initiatives that aspired by the rakyat as well as the national agenda. I think.
Thank you. Thank you, Shazib. Dr. Arifin.
Okay. For me, I'd like to thank all the stakeholders and also for the organizer for inviting me. And we at MPLS, we very much welcome this kind of collaboration because, for example, at Smart Grid, it is not just technology, it is also the capacity building, it is also the regulatory, it is also economics and many others. So I hope we can have this kind of model in our ventures in the future so that the various aspect of certain implementation of policies, not just technology, will be done in this manner so that it will be easier for the implementation to be done, in the reality, not just technology in isolation. Thank you.
Thank you, Dr. Arifin. But I think I would like to give a couple of minutes to Dr. Izam, because to me, he's handling the key to the future. It's about the manpower requirement, the engineers of the future. How higher education, in this case, College of Engineering, Unit 10, are responding to this.
Actually, Tan Sri, this is a very important question because as an education provider, we actually provide the future for Malaysia. We provide future engineers for Malaysia, and it is very important for us to ensure that in whatever that we do, it is of beneficial to the country as well. So that's why we pay special attention in making sure that the quality of education that we give must be at the right level. And also we must actually always check with our stakeholders, our advisory panel, our external examiner to make sure that we are relevant, not just for now, but also at least 5 years to come when the students come in and graduate later. So that's why our main target is we can't teach everything, but we teach enough for them to learn new things as they go along. I think that is the most important thing that we need to teach them. Thank you.
Okay, and I hope in the spirit where we are, they have also to be imbued with the spirit of continuous learning. Otherwise, when I started in TNB, the cellular just came on board. There was this automatic telephone using radio, ATUR, the big, that you carry. That's only 20, 30 years ago. But today, you have these 5Gs coming. Well, it's already here. So the user is one thing, but to be also a possible participant, producer, in terms of using technology in order to produce new technologies adapted or applied in, let's say, smart grid or research in other areas and so on. You need those people who will be up to date in their own knowledge and so on through continuous learning. So thank you very much to all the three panelists. I would like to also take this opportunity to thank all the participants who have been following us, but also my people at Might. Well, they imposed on me to chair this, but I enjoyed it, I must say. But they are the people behind the scene who make this session possible. So thank you very much, and thank you. I hand you back to Farah. Assalamualaikum warahmatullah.
So, ladies and gentlemen, we have finally come to the end of our webinar. We do apologize that it dragged on a little bit, but the conversation, I believe, was very fruitful and very productive for everyone. We would like to express our sincerest gratitude to all our speakers and moderators, Tan Sri Tajuddin, Prof. Izham, Dr. Harifin, and also Encik Razib for sharing their thoughts and their insights on the smart grid. Thank you to all of you who have joined our session today. We hope you have greatly benefited from it. We do look forward to seeing you at our next webinar session. Follow us on Might Malaysia's Twitter, IG, and Facebook and website for further information. Alternatively, you can contact the Secretariat to subscribe to Mike's webinar series and also our monthly newsletter. For the Smart Grid awareness activities and information, you can follow the Smart Grid for Smart Nation social media platform. Have a nice evening ahead. Take care and stay safe.
Thank you. Assalamualaikum.
Salam.